Welcome everyone to the second episode of my Unity tutorial series. I'm Gary House, and if you're new here and you like the content, feel free to hit that subscribe button and turn on notifications so you don't miss out. This series is all about Unity features, tips, and tricks with a fresh tutorial dropping every few weeks. Today, we will be working in Unity 6.2 and we're building a snowstorm centered around an Art Deco themed lighthouse on a frozen shoreline at night. We will be using Shadergraph to create a lit shader and HDRP for snow buildup. We'll also explore VFX for snow and ice, including some great asset store tools. And I'll be giving away the Shadergraph, the custom shader ball, and my Lighthouse model, and all associated textures. You can use this content in your own projects. Links will be below. With all that being said, let's chill in the serenity of the snowfall. Let's start with the shader ball scene overview. You can see here we have 3 copies of the custom shader ball model I put together for this project. The shader ball is designed with Art Deco design in mind. It has a base, which holds our Macbeth chart, the 3 spheres, a central stand area, including a luminous center, the shader ball housing on top, also with luminous tubes, a glass center, and a volumetric spotlight. The individual components include a chrome, 100% roughness, and glass spheres. First, the shader ball on the left uses tileable textures converted from Adobe Substance Sampler, in this case a dark worn steel. The shader ball in the middle is using a custom set of textures I generated in Adobe Substance Painter, a green patinaed silver-like metal. The third shader ball uses concrete textures generated in Substance Sampler. Like the first shader ball, these textures are also used on concrete items in the lighthouse scene. All 3 of these shader balls are using the same custom shader graph I put together, and I called it Snow Buildup 2. We will take a look at that in a little bit. From this shader graph, I created materials for each object in the shader ball scene as well as a lighthouse scene. Let's take a look at the material on the center shader ball and look at its features. I have this one set up as an opaque shader. We have the surface type set to opaque and our material type to subsurface scattering. Under the exposed properties, we have base color, where we can also tint our base map texture. Then we have our base map with tiling and offset controls. Next is our mask map for controlling our metallic, smoothness, and ambient occlusion. These are packed maps. Then we have our metallic and smoothness slider controls. Then our normal, normal scale, and normal tiling controls. And next is our snow buildup section of the material. We have our snow albedo, snow normal, and snow mask maps, as well as snow normal strength, followed by snow tiling. Then finally, our snow control section of the material. We have snow direction, snow intensity, snow remap, our snow glitter size, and our diffusion profile for subsurface scattering. This material does not require subsurface scattering, but when active, it really adds to the quality and softness of the snow building up. I want to talk about the environment here in the shader ball scene. To keep the development of this tutorial focused on our snow buildup effect and our lighthouse, instead of recreating everything I wanted to have in the environment, I relied on a variety of third-party assets found on the asset store, as well as some Quixel Megascan snow piles and ice chunks from fab.com. In this scene, I have nature manufacturer's Ice World assets, specifically a shader, as well as a snowstorm asset from the asset store. The ice utilizes parallax occlusion to make the ice look like it has volume and depth. This is assigned to a plane which sits over my half-dome floor, which has a glowing grid on it. With the snow flurries, I modified this VFX graph particle system in the snowstorm package from the asset store. This VFX graph features a spawn rate of 6,000 particles and a maximum capacity of 18,000. There is also a camera property tied into a few connections shown on the left of the graph. Controls for velocity random, lifetime random, position shape, and I define the size as 30 in X, 5 in Y, and 30 in Z. Following this is an angular velocity block with random in Z. Next, a scale XYZ random per component block. This is then fed into the update particle block, and you can see a gravity block, turbulence, a force block, and tiling warp positions. There is also a random float fed into the X of the force block. The final section for our Snow SB visual effect graph is the output particle unlit quad. Another random float is fed into the text index, and the set size over life is controlled by a curve as shown here. Now, let's switch to the lighthouse scene. The entire scene is lit by real-time lighting and global illumination. There's a primary global volume, and then my FX volume is parented to the volume profile. I have a number of post-processing effects, including hardware ray trace reflections, screen space ambient occlusion, as well as several other post-processing effects shown here. First, the vast majority of this frozen lakeshore environment is from the Winter Tundra Asset Store package. I purchased this winter set on the Asset Store, and I used it for the frozen lakeshore environment, trees, boulders, terrain, shoreline, and distant mountains, and a ton of other set dressing props. Great for populating wintry scenes. For the ice pack surface, I used one of nature manufacturer's Ice World shaders for the icy surface, creating a dark, moody frozen lake. There are a number of effects in the scene, including several snow particle systems, as well as a fully volumetric, soft snow blowing effect. We will go through a few of these by isolating them individually. Let's start with the first of the snow particle systems. Identical to the snow blowing effect I discussed in the shader ball scene, it just has a lot more particles. Next, let's look at the patchy snow wind effect. This effect is more subtle and meant to build up cloud-like areas of blowing snow. You can see here the settings for this system in the visual effect graph. Let's start with our spawn rate, which is set to 512, and our initialized particle block. Our max capacity is set to 1024. There is a set velocity random block with some values that work well for this scene. There is also a set lifetime block with a minimum of 2 and maximum of 12, as well as a set scale .xyz block which has a random float block plugged into scale with values of 5 and 14. In the position sequential circle block, there are a few values here, but pay attention to radius. It is set to 25 units. Now, in the update particle block, we have a turbulence block with some different values. Always make sure that the values in this block work for your scene and needs. Next, a force block set to absolute and given random float block for both X and Y. And finally, in our update particle block, we have a tile warp positions block. This block ensures that particles exiting one side of a volume appear to seamlessly re-enter from the opposing side, creating the illusion of an infinite particle system. The last section of this graph is our output particle quad. Flipbook is enabled, soft particle is set, blend mode is additive. Our flipbook size is 2 by 2. The main texture is set to snow _on_wind_4. Next, the set text index block has a float value 4 set in the Y tiling of the sprite. Next, an orient face block for keeping our particles facing the camera. Then a size over life block with a modified curve to get the results I need for our scene. And finally, a color over life node with a gradient to control tinting and changing the opacity of our flipbook sprite. All of this defines the look, size, behavior, and placement of our particle effect. The volumetric ground snowblowing effect. This effect is truly volumetric. It uses a 3D volumetric shader and material which is assigned to a game object with a local volumetric fog component. The object and material in the scene started from the ground smoke effect sample found on the volumetric samples in the HDRP package. You can see here in our scene the effect of the rolling patchy fog effect along the ground, as well as the fact that our volumetric lights are actually casting shadows into the fog volume. Really cool. Let's take a look at the material in the inspector. I duplicated the original material and I modified it for my needs and called the material ground snow material. There are also several options available for this material. Single scattering color creates an override color for the fog. Fog distance controls the density. The lower the value, the more dense the fog appears. Our blend mode is set to additive. And under the exposed properties, we have our color section, which includes top and bottom colors of the effect, as well as color gradient end, which controls the color blend between top and bottom. Next, the noises section, which includes the shaping noise driven by a texture, also found in volumetric samples, followed by tiling and flattened slider controls. Then a detail noise texture with a slider for controlling the repetition. Finally, the wind section of our material, wind speed, wind direction as defined by X, Y, and Z values, and the counterflow speed to add more realism to the effect. Our snow buildup shader. Let's start on the right side with our graph settings. This is an HDRP lit material. Material type is set to mixed as I added subsurface scattering to the shader to soften the snow on our game objects. Its surface type is also set to opaque. I also have double-sided enabled. It is set to receive decals and SSR, and transmission is enabled for the subsurface effect. In the blackboard on the left, I have created a number of exposed controls that are used in our Shadergraph. I have divided the controls into 3 distinct categories. The first category is our primary controls. This houses double-sided is on Boolean, a base color, our base map texture 2D, our mask map texture, metallic and smoothness floats, a normal map texture, normal scale as a float, and a vector 2 for texture tiling. The second category is our snow section, which includes our snow albedo texture, our snow normal map texture, a float for normal map strength, a snow mask texture, and a float for snow tiling. This all controls how the snow tiles. The final category of our blackboard houses the additional snow controls to refine the look of our snow buildup. These include a vector 3 for snow direction, a float for snow intensity, a vector 2 for snow remapping, and floats for both snow glitter size and snow glitter intensity. Now, onto the actual graph construction. Our graph is divided into 6 distinct areas, not including our vertex and fragment blocks for outputs. At the top, we have our color group for controlling our colors, followed by our normals group with controls for our object normal maps, and then our mask group for masking. At the bottom, we have our snow glitter group, and finally on the left, we have our snow overlay blend group. Let's start here. The first node is a normal vector set to world space. This is piped into the A slot of a dot product. I also dragged in our snow direction vector 3 and connected it to the B slot. The output of the dot product is connected to a saturate node, so our colors are clamped. This is connected to a multiply with the B slot coming from our sample texture 2D and texture 2D asset. This is connected to yet another multiply node which has its B slot driven by our snow intensity float from our blackboard. The output of our multiply node is piped into a remap node which is controlled by the snow remap vector 2 from the blackboard. This is then plugged into a saturate node and connected to lerp nodes in the other groups, which I'll talk about in a little while. Next, let's look at the color group. First, our primary tiling vector 2 is connected to the UV input of a tiling and offset node. This is then fed into a sample texture 2D node's UV slot. Our base map is connected to the texture slot. This is then connected to a lerp node's A slot, while the B slot is fed from a triplanar texture node. This node is fed from our snow albedo map, and tiling is set from our snow tiling float. Now let's go back to the lerp node. The T slot is fed from the output of our saturate node, which comes from the snow overlay blend group. The out of the lerp node is sent to the base color of our fragment. Alright, now onto the normals group. This group is very similar to the colors group, but we are dealing with our normals instead. Once again, we have a tiling and offset node fed by our primary tiling vector 2. The tiling and offset node is piped into the UV slot of our sample texture 2D, which is also fed by our normal map texture. This is then fed into the in slot of a normal strength node, its strength then controlled by the normal scale float from the blackboard. This group also has a triplanar texture node, which is fed by our snow normal texture, as well as our snow tiling float. The triplanar node is connected once again to a normal strength node, which is controlled by the snow normal strength float. This is fed into the B slot of a lerp node, while the A slot is fed from normal scale and strength node. Finally, the T slot is fed once again by the output of the snow overlay blend group. Our lerp for the normals group is sent to the normal tangent space of our fragment. Next, our mask group. Again, we will start off with a tiling and offset node fed by our primary tiling. This is then piped into a sample texture 2D node's UV slot. Our mask map texture from the blackboard is connected to the texture slot of the node. The red channel output is then multiplied by our metallic float. The green channel output is piped to a lerp. The alpha output is piped to a multiply node, which is also fed by our smoothness float. This is then fed into another lerp's A slot. Toward the bottom of our mask group, we'll look at another triplanar node fed by our snow mask texture and our snow tiling float from the blackboard. This is then sent to a split node where R, metallic, is sent to our first lerp node in this group. G, ambient occlusion, is sent to the second lerp node. And A, alpha, smoothness, is sent to our add node in the snow glitter group, which is then fed into the third lerp node. And now let's look at our snow glitter group to close this out. We have our snow glitter size float connected to the simple noises scale slot. This is then piped into a remap node. I set some values here on the in min max and the out min max slots that work with my snow material. You could also expose this in the blackboard as an option. This is then fed into a multiply node, and the B slot of this node is fed from the snow glitter intensity float from the blackboard. This is then fed into the same add node as the alpha channel from the split node in the mask group. We have to go back quickly to our mask group for connecting each of our lerp nodes. The first lerp is connected to the metallic channel of our fragment block. The second lerp is connected to the ambient occlusion of our fragment, and finally the third lerp is piped into the smoothness slot of our fragment block. That's our shader. Now, let's look at the shader and material in action in the Lighthouse scene, with nearly all of my objects using this material to show the buildup of snow on top of each one. And there you have it. The frozen lake scene is complete. With cold, blowing snow swirling around our Art Deco lighthouse, we get a sense of the frigid environment in which it sits. A hopeful beacon for intrepid sailors during other, warmer times. I appreciate you watching to the end and hope the tutorial has been helpful. Feel free to comment and leave questions. I will do my best to respond. And stay tuned for the next tutorial. If you feel up to it, hit the like and subscribe and let me know what Unity features you want to be covered. Thanks for watching and see you again soon.